Hello everybody, welcome to Software Crafters Barcelona. Thanks to you for being here today, and thanks to all of our amazing sponsors for making this day possible. We are Antonella and
I'm Erifyli.
And today we're going to talk to you about functional programming versus object-oriented programming. We wanted to talk about this topic because we were interested in how to combine the functional programming patterns into object-oriented. And it's important to highlight that we are not experts in this matter, and this is the first time we give a talk in an event like this, so we are very excited to share with you our findings. First of all, we want to introduce ourselves a little bit. I am Antonella, software engineer at Factorial. I am Venezuelan, living here in Spain from 2 years ago. I am a computer scientist student yet. Recently I found a new passion in running, and I also love poetry. And
I'm originally from Greece, from Athens, but I've been living in Barcelona for the last 4 years. Also software engineer in Factorial HR, quite fresh in tech. I graduated from a programming bootcamp almost 2 years ago, and working professionally as a developer for the last year and a half. And yeah, my passion is beers after work, so I don't usually miss Thursdays afterwards. And I'm also volunteering in Microcode Code Women as much as I can. And yes.
Okay, let's start. So there's this big battle between functional programming and object-oriented for years, like they were rivals. But we all know that the best rivals are also big friends. So today we're going to demystify this old battle. First of all, what exactly is functional programming? According to Geek4Geeks, functional programming is a programming paradigm in which we try to bind everything that is computable into functions. And why we say try? Because it is impossible. For example, I/O operations are not contemplated into functional programming. So, no general purpose language is purely functional? Of course, this is not so black or white. Some languages such as Isabelle Hall or Agda are completely functional, but these languages are created for proven theory purpose. This is more of a spectrum. So we cannot classify a language if it's purely functional or purely object-oriented. Here we have this diagram in which we compare if a language is whether more dynamic or static, or more functional or object-oriented. Where would you place your favorite language? Mention one. JavaScript, Ruby.
JavaScript.
Okay, where would you place JavaScript?
I would put more in the middle, I think.
In the middle, like here.
I don't know. Let's say function, I don't know, because it's like general purpose, I don't know.
Okay, so you would put it more between.
Like functional functions, but then you can also implement object-oriented. So.
Okay. Okay. Someone else wants to contribute with their favorite language? Your favorite language is TypeScript. Where would you place it? Between static and object-oriented? More functional. Okay. Okay. Let's see. Okay. So JavaScript is placed over here because it's more dynamic. It doesn't have a static type system. Here we have Ruby. Ruby is the main language we use for the backend at Factorial. We're going to talk about that later on. There we have some examples such as Scala, Haskell. I don't know if you have heard of those languages, which are more functional oriented. And here we have Kotlin. And also here in this part, these less mainstream languages because are dynamic and functional, which is very rare to see. And these are Common Lisp, Scheme, and Clojure. Were you surprised by the answer? Yeah. Okay. There's another approach from Joe DeGose, which is an expert of functional programming, and he says that the comparison is not between whether language is functional versus object-oriented, but whether it is functional or procedural. And he also makes the comparison between imperative and declarative. We will see, we are introducing some concepts that we will see later on, so don't worry. Okay, what makes a language functional then? When we start to hear about functional programming, all of these mystical terms also appear, such as monads, functors, algebraic data types, category theory or lambda calculus. What is all this all about? If we focus on the main core and to start understanding, which is functions, it will be easier to understand what this is all about. Something that really helped me to start understanding functional programming back at college was whenever I had a problem to resolve, I asked myself this question. If I had to calculate this problem in paper, like for a math test, how would I write the function to do so? And to explain this, we will take a classical example of we don't like to reinvent the wheel, the Fibonacci succession. I guess at least you have heard of the Fibonacci succession at least one in your life. This is the mathematical definition of the Fibonacci succession. And if we do the exercise to try to translate this into a pseudocode, it will be something like this. Are you able to see the letters? No, right? Thank you. So Fibonacci of 0 equals 0. Fibonacci of 1 equals 1. And for the rest of the cases, Fibonacci of n would be Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? To the moment, we only had translated the mathematical definition to pseudocode, right? Well, let me tell you that this is literally Haskell. And it's very powerful because it has something that I'm going to explain now, which, can you, thank you. And that is pattern matching. Here I have the implementation of Fibonacci in JavaScript. Can you see, what's the first difference you see between the first code snippet and the second one? Please, someone can raise your hand if you see any difference. Sorry, can you lower your, raise your voice?
There's no technical details of the actual language, programming language itself. It's purely mathematical and components.
Okay, that's the first approach. Another difference is here we have an if statement, right? And here we don't have an if statement. This is what we call the imperative paradigm and the declarative paradigm. In functional programming, we don't have control flow. We don't have if statements, loops, for, while. And if you imagine a world without all of these structures, you may say that the things that you can actually do would be limited, right? We'll see that that's not so true. So as I told you, there's this declarative versus imperative paradigm. The declarative paradigm is a paradigm that only describes what the program does, and the imperative one describes how the program does it. I will give you an example. If you had to do a chocolate cake, in an imperative way, you would have all the details of the recipe with the ingredients and all the steps by steps until you accomplish the goal. And when you have to do it in the declarative way, spoiler, the only things you have are the ingredients, the goal you want to achieve, which is the cake, and the tool you need to do it. And that's it. You don't need the instructions. The machine knows what to do. You don't have to tell it how to do it. Let's give a simple example in code. So can you turn off the lights again? Thank you. So zooming an array of numbers, the imperative way would be something like this, right? This looks like the classical way when we learn programming, like zooming an array, right? And again, this is the way to zoom the elements of an array in Haskell. It's very simple. Like you only have to say the function and pass the element, and that's it. You will get the result. But also, I have found this on Stack Overflow. Someone asking how to implement the sum of the elements of an array in JavaScript, and I found this. If you see, have you ever used the reduce function? Yes, right? I think almost no one does something in this way in our daily work, right? We tend to use more this approach or that approach because it's easier for us, right? We don't have to write again and again so much code. So what's so cool with the declarative paradigm? As I already told you, it's cool because you write shorter code and it's also efficient. It has a higher level of abstraction. The implementer doesn't have to know how to do the calculus. You only ask the program to do it and it will do it. And also you avoid the so-called side effects. And why do we avoid the side effects in functional programming? Because you have no chance to introduce them. You only use the functions that are already there, and if you have to implement a new function, you always have to return what you are defining on the signature of the function. But also this carries disadvantages such as being hard to understand because it's an unfamiliar conceptual model. Almost all of us learn to program with an imperative paradigm, and it's very difficult to understand the conceptual mode of functional programming. And also, avoiding the side effects limits a lot of operations that we do in our daily work, such as catching exceptions, asynchronous processes, etc. But well, not everything's so dark. Let's talk about a very popular function that I think that probably everybody in this room have used at least one in their life, and it's map. Map is a very useful function that basically applies a function to a collection of elements. In this case, we are applying the function multiplies per 2 to this array, and we get this result. We all use this function where we don't know how it does it, right? Let's reveal the magic. So this is the implementation of map in Haskell. And I'm going to explain a little bit the syntax of the code. The first line is just the signature of the function. As Haskell is a very strong type language, we have to tell the program the type of the function. If we notice here, we are saying that map takes a function that goes from A to B. We don't have to specify which A is and which B is because A can transform to a number, to a list. But of course, it has to match, this A has to match this element. This is a big difference between, for example, JavaScript, in which you have the any type. For example, in JavaScript, we could pass a function that operates over list and then pass an array of numbers. And it wouldn't complain, right? So the next line of the code is what we have previously seen, and it's pattern matching. As we don't have a control flow if statements, we need a way to know how to calculate things. So pattern matching is a very useful tool in which the language will take the pattern that the input is being and giving a result. Okay, what does it mean? This means that it doesn't care what it has. It only focuses on if the second input is an empty list, and it will return an empty list. And the second case is taking a function and a list. This means the head of the list and the rest of the list. And this operator means concatenation. So if we have this case, we're going to return the function applied to the head of the list, concatenated with map again, we're doing a recursion, applied to f and the head and the rest of the list. I know this sounds like very strange, but let's do the first example I show you. We're going to do step by step how the Haskell compiler calculates this. So map per 2 of the array 1, 2, 3. So the first thing Haskell does is to put see where, well, check the types, and the types match, so it won't complain. And where do you think it would match the case? The first one or the second one? The second one, right? So map, what it would do is it will take out the head of the list and apply it to the function. And our function in this case is multiplying 2. And concatenate it with the rest of the list. We will apply again map multiplying 2 with the rest of the list. So now what Haskell does, for example, an imperative language, what we do now is focusing on calculating this. For example, if this would be a division by 0, Haskell wouldn't complain at this moment because of the lazy loading. It will wait until the end of the recursion to start calculating. So again, we repeat the process. We call map again. And we repeat the process. The result is multiplying 2 on the head of the list and concatenating it with map, multiplying 2 and the rest of the list. There's a typo there because this should be in brackets. We repeat the process again, and now see that we have taken out the head of the list, and what's the tail of the list now is the empty list. So now we're going to match this case. So the pattern will match the first case. And now we have results in this. This can be translated into an array of 2, 4, and 6, but it's the same representation. And that's it. It's not magic at all. It's only doing recursion with list. It's very simple, and it very simplifies our lives. Okay, as I told you, this is because of the lazy loading. And also, this is another functional programming feature that's called general programming that lets you apply a single function to different. For example, I could apply also a map to strings or other types that I define in my code. And whenever I maintain the types, what I mean is if I define a function that takes an A and returns a B, if I respect the types, I can perfectly use map. And not only map, but also the other methods. So as I told you, perfect. Look, this is all of the definitions that we have for map. We could apply it to many different types. This is because of the generic programming. So this is very different from not of the dynamic type system, because as I told you in JavaScript, we have the any type, and if in JavaScript we don't specify the type, so you could send a string but it's expecting a number. This way you could also use a single method for different types, but also maintaining or making sure that your type system will be consistent. Okay, but where's all the object-oriented programming here? I'm gonna leave you with my partner.
So I think we will be needing to switching off and on the lights all the time maybe. And my outfit is very good, but you will not see it. So to put some examples to what we've discussed before, is anybody working with Ruby? Thank you. And but anyway, even if you don't work with Ruby, do you think that Ruby is a functional programming language? Can you raise your hand if you think so? That's a good answer because exactly, kind of. It's a kind of a functional programming language because it does support first-order functions, same as other languages, same as Java, same as PHP, the language that we used to hate as Rubyists, and same as other OOP languages. However, it does not guarantee referential transparency. Referential transparency is something that we do have with pure functions, that no matter how many times we call a function with the same arguments, we will always get the same result. This is not the case with Ruby, where we cannot guarantee immutability, and this is mostly on the dev's choice to decide. So yeah, in Ruby we cannot guarantee immutability. It's only sometimes such as numbers or booleans are by default immutable, but strings, for example, are not by default, at least in the majority of the versions of Ruby. However, we should try to avoid mutation. And why that? Because mutation is a big source of bugs. It can cause things that we figure out only when we try to hunt down a bug. And whenever we modify a variable that is not mutable, it can cause effects in another side of the program that we cannot be aware of. So mutation should be handled carefully. Maybe we can establish a code or something so we can switching off the lights whenever we have snippets. Now, thank you. For example, as I mentioned, we don't have immutable string constants in Ruby. In order to make them real constants, we need to freeze them. And if we try to modify a frozen string, is the moment that we get a runtime error. Actually, in the latest versions of Ruby, this is happening by default. But if you are using an older version of Ruby, as we do for the moment, you either need to activate a command line, either you should be freezing its string that you declare. Another thing that we should be doing is design classes to be immutable, meaning that we instantiate the instance variables inside the initialize, and we don't provide any methods that could amend them. Well, I'm not sure if you can see it in the end of the screen, but you may see that if you do it with a non-functional style, we violate this principle. And when string mutability is really useful, well, in many cases, as we mentioned before, to avoid bugs crawling up, but also when we work with concurrency, when we have many computations happening at the same time, if the data structures are immutable, they can be shared across multi-threads without causing synchronization issues or without locking. Another case is security. We use strings to compare with sensitive data such as usernames, passwords, or credit card data. So when we use immutable strings, we prevent a malicious party to tamper with these ones. And another case to use immutable strings is when we use them as hash table keys. Maybe I should be doing this. We see, for example, in this case, we've used a mutable string as a hash key. So if some lines later we modify at the spot this string and we try to access the key, we cannot find the value. So this can also be a very good reason for bugs. Oops. How can we remedy this in the case of the hashes? We can either use frozen strings as hash keys. This is also happening by default in the latest versions of Ruby. Or we can use symbols instead of strings. However, although this seems the most straightforward way, just use symbols and forget everything about strings, the thing is that strings have many more methods than symbols. So it's not always possible to use a symbol instead of a string. So let's not update, let's create. If we, for example, assign a string to a variable and then we decide to change it after 20 lines and add, in this case I used the example of a movie title, and I decided after 20 lines to also add the director, and after 20 lines assigning also the date. But after 50 lines, I'm not sure which movie I'm accessing. So this can also be a very good reason of bugs. So instead of updating the same variable, the most recommended way would be to create a new one. And something also very useful in big projects, freezing strings, meaning that two identical strings are occupying the same object ID in the memory. So there is also less work for the garbage collector, and also makes things run faster, since we cache these strings for future use. If you really need a string to change, what you can do instead of modifying that fly that we saw before, you can create a duplicate of it. In Ruby, at least, we have many methods with which we can achieve the same. For example, .up, which creates a duplicate of the initial string, or string new, or something that was a bit confusing for me, the unary plus operator, which in another language does another thing, but here can also duplicate a string. Something that I didn't know, and what was very interesting for me to see, is that even if we freeze an array, it's true that we cannot add more elements to it or replace it, but we can access its elements and amend them on the spot. So the freeze method is shallow as opposed to recursive, and can be dangerous in these cases. So, as we mentioned, mutation maybe not be bad per se, but it's the side effects that come with it that can cause us problems. But in software development, we do need side effects for very interesting stuff, such as writing to a database, printing an output, or for exceptions. So side effects are difficult to avoid at all. So the best would be to find how we can live with them. And how to prevent them if they are not needed for real. In Ruby, we have some built-in methods which can cause side effects by default. The majority of them comes with a bang in the end, so this can give us a clue that we are doing a destructive action. But some of them do not come with a bang, such as the double chevron or the delete, which can be quite destructive methods, but they don't tell us from the beginning. And it's not only them. You cannot maybe read the table, but you can see the size of it, and that there are plenty of methods that can have side effects even without the bang. Exceptions are also a side effect, and yeah, good to know, because also there are many Ruby built-in methods that create side effects which should be handled. So when we use methods such as drop, it's important to know that can create exceptions and should also be handled. High order functions is another functional pattern used in Ruby. High order functions are basically a method that takes a function as a value or returns a function as a result. And in Ruby we have plenty of them. For example, lambdas and procs, which as far as I know, they're also present in other OP languages. Here, Fizzbuzz, you will see it's declared as a lambda, and here some is declared as a proc. The difference, well, basically lambda is a type of a proc, but lambda needs a specific number of arguments, whereas proc no. And they are basically a type where it encapsulates a block of code, some logic, and it can be passed to another proc or to another method and then called. And another difference that we have is that the proc breaks out the method when it returns the value, whereas Lambda returns back to the method and then it completes it. And as I mentioned, I know that we can see them in other OP languages, and we can also see it in JavaScript. This is where I think I've seen a Lambda first time, where it's basically an anonymous function, a block again of code that can be passed to another function. Such as in this example, where we pass this Lambda, this anonymous function, to a set timeout, which will console log a string after 1 minute. And some more examples of high order functions. We have map that Antonella mentioned before, inject, which is the reduce that we use in Ruby, or detect, or many other methods that we wouldn't have them available if Ruby wasn't supporting functional patterns. And I really cannot imagine myself like writing 7 lines of code whenever I wanted to use map. And another functional pattern that we have adopted in Ruby is the pattern matching that we also mentioned before, which is a mechanism to compare a value against a pattern, which is also available in other OP languages. And to start wrapping up, we wanted to have a look at the most popular languages as per Stack Overflow for the last year. We can see that, programming, scripting languages, we can see that in the most popular ones, we don't see, maybe I'm in the front, no? In the most favorite ones, we cannot see any purely functional programming language. Oops. However, we do see a lot of articles, of discussions, of books about how functional patterns are being adopted by OP languages and why we need them. So we see that we are moving from a more pure O style to a more hybrid one, where we start adopting also best practices or patterns that fit our needs from the functional programming style. And maybe the idea would be to find, in each case that we want to work, which paradigm fits us better, and take advantage of it to make cool things, such as we have in Ruby the memoization, which is, I don't know if it's another OP language, maybe yes, which is basically caching the result of a function. The function needs to be pure, but this makes the program a lot more performant and speeds up the computation. And also, it helps us test in isolation the components. And also, something that I found recently, that by testing functional components, you don't also need to go to the database that much while testing, which can also speed up the tests. We mentioned before Jonah the Ghost, the very and that he's really talking about functional programming getting adopted in functional programming patterns getting adopted in OP languages. And as we mentioned before, we see lambdas being adopted for a long time now, immutable data also for 5 years, and pattern matching that is now being adopted in Ruby and in other OP languages. And there are many more. His Twitter is really amazing to keep up with this topic. And you will see that there are many discussions about what pattern will be the next to be adopted in OP languages. And maybe I can get back to you.
So our conclusion of this is not a debate between which pattern is better than the other, because we have seen that in practice we are needing to combine them both. There's a quote from a poet, Maya Angelou, that says, "In diversity there is beauty and there is strength," and we believe that by combining these two patterns we will get more powerful code. We have this survey that we would like you to fill. You have to go to that link. Can you see it? Everybody in this room can see the link? The poll, ev.com/Antonella Requena. Okay, can you go over there and start voting? Let's see the results. It was supposed to be a QR here. I don't know what happened with the QR. All of the above. Okay. Interesting.
Uy. Pues
Okay. It's changing yet.
uy.
Okay. Okay, nice. I wasn't expecting these results actually. Okay, thank you. We are now closing officially the poll and we're moving to the Q&A.
Yes, it has surprised me that we have been talking about Ruby and functional programming, and you haven't mentioned Elixir.
Yes.
Yes, because I mean, as I mentioned, we are newbies, and I mean, for example, I'm a junior software developer. She's a mid software developer, and we wanted to talk about the language we feel more comfortable with.
It's a Ruby, you know. Elixir is 90% Ruby.
Really, I didn't know that.
Well, the format, kind of, yeah.
Okay, but it's more functional, right?
Yeah, no, totally.
Totally functional.
It's a transpiller from Elixir to
Erlang. Ah, okay. Well, good to know. Thank you for the comment.
We work at Cabify. We work 50% with Go and 40% with Elixir and 10% with Ruby.
Okay.
And we know that it's a little bit complicated, that it has a long learning curve, but it's quite interesting, very good language.
Okay, someone else?
Do you think that you can do functional programming whatever language you use?
I mean, we can adopt functional programming patterns in whichever language, if of course the implementation lets it. But that doesn't mean that the language that every language could be functional, because it also depends on the it's not only about implementing map, reduce, filter. It's not about that. It's also about the, as we explained, the style, if it's the design system type, the imperative or declarative paradigm. I mean, it's a more holistic approach. But what we wanted to highlight is we can adopt those patterns and make it work with what we need.
I would like just to put a bit of controversy for having fun. So if someone has an actual question, please go ahead. If not, I use C#, and I think it should be a bit more to the left.
Okay.
Certainly way more to the left than JavaScript. I'll explain.
Okay.
So for example, in JavaScript you don't have list building as far as I know.
No.
But in C# you have, which means that if you chain a map with a filter with a reduce, you first will do all the mapping, then all the reducing and all the filtering, but in C# you will, for each item, let's say, map, filter and reduce, map, filter and reduce. But there was a lot of movies of, and it's also implemented using monads.
I didn't know that.
Even if you don't talk about monads when running C#, actually there are some monads in C#, which is kind of interesting.
In which cases would you use monads in C#?
So most people won't use monads usually, but since you have generic types, you kind of apply some monads, not all of them. You will need that as a for that. But for example, the I enumerable, which is kind of similar to an array, but more abstract, is a monad. You will say that you have a type, A, whatever, and that you will have some kind of enumeration operation against that type, whatever type, so that will be kind of a monad.
Quite interesting. I didn't know that. Thank you.
Some links if anyone is interested.
Yes, of course. Thank you. Who else?
Just to continue the discussion, I completely agree with him because indeed I develop in JavaScript and TypeScript, but the thing is like, at least for me, it's not a functional programming yet, so it's good place it, but indeed if you want to make JavaScript a functional language, you need to install additional libraries. JavaScript for me it's just a attribute. For me it's an scripting languages.
Yes.
It provides to you some tooling, but not everything. You need additional libraries to make it pretty functional, that mainly with the use of these libraries can become more to the left than C#, but purely I think that it should be more to the right. I'm agreeing.
Thank you.
Yeah.
So you believe that Java should
JavaScript.
be more to the right, like more.
Yeah, more to the right.
Okay.
Yeah, because
well,
you
this
need-
is like it's
Yeah,
not
yeah,
very
yeah.
specific, you know. But yeah, I totally agree with you.
Yeah,
I mean,
yeah, agree. But it's good. And thank you.
who else? No more questions? No comments? No complaints? Okay, so
Sorry, you have to add anything.
yes, I apologize.
One question. Why you choose Haskell? Because you like it or because you thought that...
Honestly, because that's the language in which I learn functional programming, and I really like it, and I thought it was pretty cool to show it with the examples.
You use it only to study functional programming or also work with it?
No, in my case, I chose Haskell because I studied back at college, so that's why I chose it. But in Factorial, we don't use any functional programming language. No more questions? Okay, thank you.